So in this lesson, we are going to be talking about the laws of exponents. Now, before we jump into the laws of exponents, there are about 5 of them. Let's first of all understand the term exponential expression. Now, an exponential expression can be written as b raised to the power of n. Now, what does this represent? B here represents the base, while n here represents the exponent. Now, what does this exponential equation represent? The base here represents the number that will multiply itself, while for the n represents the exponent, that is how many times the number which is the base will multiply itself. Now let's take for example when you have that 2 raised to the power of 3. Now this can be expressed that 2 will keep on multiplying itself up to when it gets to number 3. Here we have 2 multiplied by 2 multiplied by 2, which is 1, 2, and 3. So this is going to give us 8, which is 2 multiplied by 2 give us 4. Then 4 multiplied by 2 will give us 8. Now let's take another example, like when you have 3 raised to the power of 4. So the number of 3 will keep on multiplying itself by 3 until it gets to 4. So this gives us 3 multiplied by 3 multiplied by 3 multiplied by 3. So 3 will multiply itself by itself 4 times. Now let's move over to the laws of exponents. Now for the first law, the first one says that when you have a raised to the power of m plus a raised to the power of n is equals to a raised to the power of m plus n. Now let's take for example when you have 2 raised to the power of 2 multiplied by 2 raised to the power of 3 is equals to 2 raised to the power of 2 plus 3, which is equals to 2 raised to the power of 5. Now to check this law, 2 raised to the power of 5 is equals to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. Now on the other part, when you have 2 raised to the power of 2 multiplied by 2 raised to the power of 2, if you say you want to write them separately, you will still have 2 multiplied by 2, which is the first part, 2 raised to the power of 2, multiplied by 2 multiplied by 2 multiplied by 2. So this is the first part, which is 2 raised to the power of 3, and this is the second part, which is 2 raised to the power of 2. So you can see that it's the same thing as 2 raised to the power of 5. Now this law is here to help us solve other questions like this one. When you have a raised to the power of 15 multiplied by a raised to the power of minus 10. Now how do we solve this? You can't just write in a multiplied by a multiplied by a multiplied by a then minus multiplied by a raised, no. So this is going to be equals to a raised to the power of 15 plus minus 10. Now what is 15 plus minus 10 is going to give us 5. So we have that our a raised to the power of 5. So let's move to the second law. When you have a raised to the power of m all over a raised to the power of n is equals to a raised to the power of m minus n. Now let's take for example when you have 2 raised to the power of 5 all over 2 raised to the power of 2. Now this is equals to 2 raised to the power of 5 minus 2, which is equals to 2 raised to the power of 3. Now 2 raised to the power of 3 will give us 8. Now this law, to prove this law, like when you have 2 raised to the power of 5, it will give us that our 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2 1 2 3 4 5 all over 2 multiplied by 2. Now these 2 can cancel these 2 and these 2 can cancel these 2. What are we left with? We just left with 2 raised to the power of 3, which is still equals to 8. Now let's solve this other question. When you have like 5 raised to the power of 120 all over 5 raised to the power of 80. Now when we apply that law, we're left with 5 raised to the power of 120 minus 80. So it is going to give us 5 raised to the power of 40. Now let's move to the other law. And of course, before we forget, we have to know that in this particular law, a cannot be equals to 0. I mean, this a here cannot be equals to 0. Now, for the other law, for the third law, when we have anything that is a raised to the power of 0, it is equals to 1, provided that a is not equals to 0. That is, a should not be equals to 0, because you can't have 0 raised to the power of 0 can't be equals to 1. So, so far that a is not equals to 0, and you raise it to the power of 0, it will give us 1. Now let's take for example, when you have like minus 50 all raised to the power of 0, this is still equals to 1. Even when you have x plus y all raised to the power of 0, it is still equals to 1. Now let's solve this. When you have minus 5 raised to the power of 0, what will this give us? Since the minus is not raised to the power of 0, this is going to give us minus 1, because we're just going to raise 5 to the power of 0, which is 1, and we'll still bring back our minus. Now let's keep moving. Now for the fourth law, we have that our a raised to the power of minus n is equals to 1 all over a raised to the power of n. Now let's take for example, when you have 5 raised to the power of minus 3, it is still equals to 1 all over 5 raised to the power of plus 3. Now also when you have 1 all over 7 raised to the power of minus 2. Now what will this give us? This will give us 7 raised to the power of 2. So 7 raised to the power of 2 will give us 49. Now, without wasting time, let's move to the next law. Now the next law says that when you have a raised to the power of m all raised to the power of n, it is equals to am multiplied by n. Now let's take for example, when you have 3 raised to the power of 2 all raised to the power of 2. Now this is equals to 3 raised to the power of 2 plus 2, which is equals to 2 raised to the power of, which is equals to 3 raised to the power of 4. 3 raised to the power of 4 will give us 81. Now let's take another example. When you have 1 all over 4 raised to the power of 2 all raised to the power of minus 1. Now first of all, we are going to apply the law we just discussed about. So what does this give us? To be equals to 4 raised to the power of minus 2 all raised to the power of minus 1. Then we now apply this law, and this will give us that our 4 raised to the power of minus 2 multiplied by 1 minus 1 multiplied by minus 1. So this minus is going to cancel this minus, and be left with 4 raised to the power of 2, which is equals to 60. Now for the last law, when we have a raised to the power of m all over n, this is equals to n roots a raised to the power of n. Now let's take for example, when we have a raised to the power of 1 all over 3, this is equals to the cube root of a. Now another example, when we have like our 9 raised to the power of 1 all over 2. Now what will this give us? This will give us the square root of 9, which is equals to 3, because this square root is an invisible 2, which is this 2. Now let's take for another example, when you have like 4 raised to the power of 5 all over 2. Now what will this be? This will be equals to the square root of, which is this 2 here, 4 raised to the power of 5. So we can naturally find the square root of 4. So this will give us 2 raised to the power of 5. 2 raised to the power of 5 is equals to 32. Alright guys, this is where I'm going to draw the curtain. Thanks for watching. So with these laws of exponents, you can solve many exponential equations out there. Just apply them and solve them calmly and you get your answer. Don't forget to like and subscribe. Bye. See you on another of my videos.